everyone, this video is all about total and net signed area. So to find out what those are, let's do an example. Same function as what we've been doing the entire time. The function is going to be y of x equals x squared minus 4. So y of x equals x squared minus 4. So we're going to take a close look at that. I want to find, suppose this is x equals 3. I want to find this total area here, or I want to find this area here. Well, let's go ahead and do our definite integral. So I guess this is x equals 0. If we calculate the area in the way we've been doing, we will take the definite integral from 0 to 3 of our function y of x. So definite integral from 0 to 3 of x squared minus 4 dx, and we know how to do that by now. We're pretty good at it. So we put it in a box and then we find the antiderivative of that thing. We add 1 to the power, we get x cubed, divide by the new power, so divide by 3, and of course minus 4x, and we're integrating from x equals 0 to x equals 3. That means that we put in x equals 3 and we get 3 to the power of 3 divided by 3 minus 4 times 3. What do we get? So that's going to be 27 divided by 3, which is 9, minus 12. So that's going to be negative 3 units squared. Because remember, we're doing area. What the heck, though? Negative 3? Area is supposed to be positive. Ah, right, of course, I forgot. This area here, under the calculation we just did, that area is going to be negative. So everything between 0 and this point, better use a different color, everything between 0 and this point is going to be negative. What is that point? Well, that's where our function y of x crosses the x-axis. Clearly, that's when y is equal to 0, and so that must mean x is equal to 2. So actually, the integral from 0 to 2, the definite integral from 0 to 2 is actually going to be negative area. What we just worked out here was actually this pink area minus the blue area. That's what we just worked out, because all that blue area between 0 and 2 is going to be negative, because the rectangles would have negative height when we actually differentiate the area function. Way back in the first video we talked about this. Okay, so what we worked out was the pink area minus the blue area, and that's called the net signed area. So the net signed area is actually just the definite integral from x equals 0 to x equals 3. In other words, we don't care whether it goes above or below the x-axis. We just want the net signed area, which is going to be the area of everything above the x-axis, so the pink area, minus the area of everything below the x-axis, so minus the blue area. Okay, so that's the net signed area. That's the net signed area. What if I wanted to work out the blue area plus the pink area? Blue area plus the pink area. What would I do then? So let's go back a bit. So the blue area plus the pink area, how would I go about that? So this is x equals 2 still. Blue area plus pink area. Plus pink area. Well, let's make an observation here. So think back to the first video again where we talked about the area function or the antiderivative. Well, the definite integral from 0 to 3 of y of x dx, that's actually going to be equal to a of 3 minus a of 0, where a is the area function or antiderivative, whatever you want to think of it as. So a of 3 minus a of 0, I'm sure you're going to have no problem with me saying this is the same as a of 3 minus a of 2 plus a of 2 minus a of 0. It has to be the same because all I did was subtract a of 2 and add it back on again in the middle there. So I didn't change anything. Remember, a of 2 is just some number. And of course, a of 3 minus a of 2, well, that's going to give us the pink area. So this is going to be equal to the definite integral from x equals 2 to x equals 3 of y of x dx plus, and this is going to be negative the blue area, so negative the blue area, plus the definite integral from 0 to 2 of y of x dx. So, well, I've done the wrong calculation, haven't I? Because this a of 2 minus a of 0 is going to give us negative the blue area. This definite integral from 0 to 2, we already calculated, that gives us negative the blue area. So what do we need to do? Well, if this is negative the blue area, then we should take the negative of that. If we take the negative of that, then that's going to make it positive again. So actually, instead of a plus here, we should have a negative. And therefore, the blue area plus the pink area is the same as taking the definite integral from x equals 2 to x equals 3 of our function y of x. And then this time we're going to subtract the blue area. So we're going to subtract the definite integral from x equals 0 to x equals 2, rather, which gives us the blue area. So let's go ahead and do that. Use a different board. So this is the same as the definite integral from 2 to 3 of the function x squared minus 4 dx. And this time we're going to subtract the definite integral from 0 to 2 of x squared minus 4 dx. And so that's equal to, as usual, x cubed divided by 3 minus 4x. And we're taking that from x equals 2 to x equals 3 minus x cubed divided by 3 minus 4x from x equals 0 to x equals 2. Now, this is equal to, let's work out the first one first. This is equal to 27 divided by 3, which is 9, minus 4 times 3, which is 12, minus 2 cubed divided by 3, so 8 divided by 3, minus 4 times 2, so minus 8. Okay, now minus, let's work out this one. Well, when we put 2 in, we're going to get 2 cubed divided by 3, well, that's just 8 divided by 3 again, minus 4 times 2, so minus 8. And then we're just going to be minusing off 0, aren't we? Because when we put 0 into both of those, we get 0 cubed divided by 3, which is 0, and minus 4 times 0, which is 0 again. So we don't need to worry about the other part. So really what we have here is 9 minus 12 is negative 3 minus, and we got 2 times 8 over 3 minus 8. So this is equal to negative 3 minus 2 times, let's just simplify this. So 8 is the same as 24 divided by 3. So 8 is the same as 24 divided by 3. So we got 8 over 3 minus 24 divided by 3. So this is equal to negative 3 minus 2 times negative 16 over 3, because 8 over 3 minus 24 over 3 is negative 16 over 3. And that is equal to negative 3 plus, what do we got here? Negative 3 plus 16 times 2 over 3, so plus 32 over 3. And of course, negative 3 is the same as negative 9 divided by 3, plus 32 over 3. And that gives us 23 over 3. And I'm running out of space. That's the same as, so 7 times 3 is 21, remainder 2. So 7 and 2/3. And since we're working out the total area this time, it's an area, we better include our units squared. So this is the total area. Total area. So, just a reminder, let's go back to the diagram. When we worked out the net signed area, it was basically the pink area minus the blue area. What we just worked out here was the total area, which actually should be the blue area plus the pink area. And of course, don't forget, this is here, the negative blue area. So we had to minus it instead of adding it on. Otherwise, if we just added it on, we would have been subtracting the blue area from the pink area. So total area is blue area plus pink area. Net signed area is pink area minus blue area. And to work out the total area, whenever you have some parts of the function going below the x-axis and some parts of the function going above the x-axis, you need to split it up like we did here. So here we split it up, and we went from x equals 0 to x equals 2, and then from x equals 2 to x equals 3. All right, thanks very much for watching. I hope that clears up integration for now. Don't forget to take a look at the notes and have a go at the exercises. All the best. Take care. Bye.